In today's video, we're going to go over Proton N-NMR. And with this particular problem, I'm going to show you how to find out what the molecular formula is with just the information that's provided. So in this problem, we're given the mass to charge ratio, which is 100. So the only thing you have to do is put 100. Then we're going to subtract a process of elimination to find out exactly how many carbons and hydrogens that we and oxygen that we have in this particular problem. So this is the information that's given. It tells us that we have a mass to charge ratio of 100. Oxygen has an atomic mass of 16, and it contains only carbons and hydrogens. So 16 is the mass for oxygen, so we're going to subtract that from 100. That's going to be 84. So we'll write oxygen out here to the side. In this problem, it tells us exactly how many hydrogens we have, and each hydrogen has a molecular mass of 1. So if you add this up, 6 and 3, 9, 1 is 10, you'll have 12 hydrogens. So if you subtract 12 hydrogens will give you 72. And it says it only contains carbons, hydrogens, and oxygen. We know that carbon has an atomic mass of 12. Carbon, I'll write it to the side, carbon has an atomic mass which equals 12. So the only thing you have to do is take this 72 and divide it by 12. So you take 72, you divide it by 12, and that'll give you 6. So you'll have six carbons. So this other 72 here would be 0 because this here will be your 6 carbons. So your molecular formula for that would be you have 1 oxygen, and it tells us here that you have an atomic mass of 16 of 1 oxygen. So you got 1 oxygen, you have 12 hydrogens, and you have 6 carbons. So your molecular formula is going to be C6H12, and you'll have your oxygen here. And then just review what I did there with the carbons, because when I first learned this, it was a bit confusing. Carbon has an atomic mass of 12, and you have only 72 left to account for. So you're going to divide 72 by 12, and that gives you 6. That lets you know that each carbon represents 12, and you got 6 of those 12s. That's going to add up to 72, and that'll give you your molecular formula.